Welcome to our probability class. To start with, probability is a very applicable course which happens in our daily lives. To start with, the simple definition of probability is simply the likelihood of an event occurring. So it's simply the likelihood of an occurrence. Now, probability has a number of properties which we call axioms. These axioms are sort of formulas that will guide us. To start with, I'm only going to look at maybe 8 for now. Probability shouldn't exceed 1 or shouldn't be a negative. So the rule of probability is that it should exist between 0 and 1 for a sample size, a sample space to exist. The probability of an event A occurring is simply given by the number of elements that A has over the total number of events. So if we have 4 apples and 6 bananas, the probability of picking an apple is simply 4 out of the total events. So 4 out of 10, the total fruits that we have in total is 10. So this is what we call our probability of A. So the event occurring is simply the number of those events, A, divided by the total sum of all events in the sample space. Then the complement, therefore, is simply what you don't have. So the complement of A is simply 1 minus A itself. So in this case, if A is 40%, what is the complement of A? 60%. If A is 10%, the complement of A is what? 90%. So in short, A and its complement must always add up to what? 1. Now that's a brain mark that you shouldn't forget. So complement is given by a dash or a small c at the end. So simply means that the two must add up to 100. So far, are we together?
Yes, Collins.
All right. Then the other rule is that when you're uniting A and B, we use the formula A union B. So to unite these equations or sets, we have probability of A plus probability of B minus the intersection of A and B. Are we together? So we also have the probability of A intersection B. Now this is a prostitute formula which has about 5 ways of doing it. The first one, you simply multiply the probability of A times the probability of B. This is the most dangerous and basic formula. To intersect is simply to multiply. And the word synonymous to intersection is the word and. So whenever you hear A and B, they're asking you to multiply them or to intersect them. Then we already saw that from the union set, there was an intersection here. Now just to explain this formula, like I said, to unite is to add. So if you have probability of A plus probability of B, when you add these two, you subtract the intersection. So it is what A has plus what B has minus what is the common denominator, the intersection, which is here. So for instance, if you're taking 3 courses and the other one is taking 3 courses, but you're meeting in QM. So you add 3 plus 3, you subtract the QM because you're going to duplicate it. Now, if you bring this guy this side and this guy the other side, our formula for the union set or the intersection will be another one. So this will be probability of A intersection B is equal to the probability of what? A plus the probability of what? B minus the probability of the union set now. So this is formula number what? Number 2 of the intersection. Remember, the first one is called the basic rule. The first one is called the basic rule. Okay. And the next one is called probability of what? From the union set formula. Who remembers what they say? The second formula for intersection is probability of A plus what? Probability of B minus what?
A intersection B.
A union B, because here there's intersection.
Yeah.
Union means what? To add. And the other word for addition, we say what? The word or. Then we go to what is called conditional probability. Conditional probability is a pattern. So this pattern is under Bayes' theorem. We just drop the bottom guy here, probability of B. Then you intersect these two here. A intersection B. It doesn't matter B intersection A or A intersection B. It's okay, but the key thing is you drop the denominator down there. Suppose we started with B given A. Can somebody expand this for me? How do we get the, what goes down? What goes down? Probability of what? Just follow the pattern.
Probability of A.
Yes, probability of A. So we put the probability of A here down. Then on top, what are we going to have? Intersect these two. B intersection A or A intersection B. It's the same as 2 times 3, the same as 3 times 2. It's not a problem, but 2 divided by 3 is not the same as 3 divided by 2. So don't mix up. That's why I'm emphasizing. Start with this one, goes down there. All right. So we go now to breaking down this formula. So this one can become an intersection set formula by cross multiplying. So probability of A intersection B, therefore, will be what? Multiply A given B, multiplied by what? The probability of B. So the trick is you should ensure that these ones are almost adjacent, they're kissing each other. Then this another intersection is what? A intersection B is got what? You multiply B given A, multiplied by what? By the probability of A here. All right. So these are the formulas that I'm going to dominate on for now. Now, you need to understand that this is the toughest part of probability, because if you do not understand these formulas, then you're doomed. Then there's what we call theorem 2. Sorry, to add. If you're given probability of A, you simply add the intersections of A intersection B plus A intersection B, but the complement should be on the other letter, which is B. In short, we are looking at the letter which is common. There's A here and there's A there. So if you have intersections that are many, A intersection B plus A intersection C plus A intersection D, what letter is common throughout? It is letter A. So that is what we're going to call a subjective formula. This is a very important theorem, and you need to understand it because we're going to expand it on the tree diagrams. Okay. So we can look at an example, then we look at the examples we had in class. So understanding these formulas is going to give us a grip of applying them in the examples that we had in class. So if you're given in an instance that a probability of A is 0.4. Probability of B is 0.3. And probability of A given B is 0.5. Let us find 5 things. Number 1, the probability of A intersection B. Number 2, the probability of A union B. Number 3, the probability of A complement. Number 4, probability of B complement. Number 5, the probability of B given A. Let's try these ones here. Now, whenever given a slash, just know that there's conditional probability. So I encourage you to expand it first for us to find this first part. So this is part A, part B, part C, part D, and part E. So to find part A, let's expand first the given condition. So A given B, who remembers how do we expand this? Which guy goes down? The bottom
B.
guy.
B.
So we put the B here. Then on top, what we have? We intersect the available letters. There are only 2 letters there. A intersection B. We usually love to start with a letter which comes first in the alphabet. But even B intersection A is still okay. Then you replace what we have. What do we have? We have everything else except the intersection, right? So where there's A given B, we put 0.5. Where there's intersection, we don't know. And probability of B, we're given as 0.3. All right? Then you cross multiply. So 1 times A intersection B is simply A intersection B. 0.5 times 0.3 is 0.15. Are you together? So this is how we find our intersection. But I also told you the shortcut that whenever we're given A given B, just multiply this with its base. If you think of parana, obviously we get automatically an intersection. A given B, multiply by B. A given Y, multiply by Y. Whatever is down should be the multiplicand there. Let's see if we're going to get the same answer. What is our A given B? 0.5. What is our B? 0.3. And what do we get when we multiply these two? 0.15. Are we together? Is that clear? All right. Then let's go to A union B. Who remembers the formula for A union B? A union B is given by what? It's a most faithful formula which doesn't change. It's the probability of A plus the probability of B minus the intersection of A and B. So our A probability was what? 0.4. Our B probability was 0.3. The intersection is 0.15. So this simply means that if you get the intersection wrong, you therefore get the what? The union set formula wrong. So 0.4 plus 0.3 minus 0.15. So in this case, when we sum this up, we're going to get 0.55. So this is our union set formula. And this is our union set answer. Now, I expected a question here to say, why didn't we just multiply probability of A and probability of B, since we know that intersection is simply multiplying and we have A and B. Like I said, that is the most basic and dangerous formula. You can only use that aside this. So this overpowers theorem 1. So when this one is there, you start from here, don't multiply them directly. But if you're just given these two, you would simply multiply them as they are to get the intersection. Are we together? All right. then how do we get the complement of A? Complement of A is simply 1 minus A itself. Complement of A is simply 1 minus A itself. So who can tell us what's the complement of A? If our A is 0.4, what is the complement of A? (0.6). They should add up to 1. So what's the complement of B if our B is 0.3? Anyone? Nana? What is the complement of B? Yes, Ronnie?
Sorry, Collins, I'm not so sure. I'm just trying to follow up. I joined in late, so I would have to go through the lesson again.
So the complement is simply the opposite of this. If A is 0.4, the opposite or the difference from 1 is the complement. So A is 0.4, the complement is 0.6. B is 0.3, the complement is 0. What?
7.
0.7. All right. I love it when my classes are interactive. Those who joined late, I want to take you step by step because this is the most dominant topic in your exam and the killer topic. So once you get it and you're comfortable, the rest are easy. All right. So that is how we find. So since the probability of so to find the complement of A is simply 1 minus A itself. So since our A was 0.4, 1 minus 0.4, we get 0.6. And the formula for the B complement is simply what? 1 minus B itself. And our B was 0.3. So how do we find the complement? 1 minus 0.3 to 0.7. And now we're asked to calculate the probability of B given A. Who can expand this for us? Who remembers the explanation, the expansion using Bayes' theorem? So let's go together. What goes down? Probability of what? A. Then what do we put on top there?
Is it not A intersection B?
Good, A intersection B. So we found our A intersection B as 0.15. Then what is the probability of A? Already given as 0.4. So when you divide this, what do we get? 0.15 divided by 0.4. We get 0.375. So I need you to build up your information on this. So before I go to the tree diagrams, you must also understand that there are two conditions that are called mutual exclusiveness and independence. So whenever you get your intersection as equal to 0, it means the events are mutually exclusive. So it means A and B have nothing in common. So the term that we use is called mutually exclusive. Okay. And we also have independence. If A times probability of B is equal to 0, it means they're independent. Or we actually say if A given B is equal to probability of A, or if B given A is equal to probability of B. Take note that here for these ones just conditions, you need to maintain the top guy. All right. A given B is equal to A. B given A is equal to B. Regardless, whatever is on top, we maintain the top guy. So if A times B is going to give us probability of A intersection B, we call that these are independent sets. Or we can use any of them, which ones you like, to verify that these are independent events. Not zero here. The zero is only for the intersection. So I have another class at 20. So if you don't understand so much, please don't worry. The first time you don't usually get to understand as much, but I'll try so much to demystify this. So let's do this together from what we just did. So can somebody help me? Let us find the intersection of A intersection B. What did we say? How do we find the intersection of A intersection B? How do we compute the intersection of A intersection B?
I think you multiply A and B.
We can't multiply these two if there's a conditional probability. So it is B given A, you multiply it 1 times what? The bottom guy. Which bottom letter do we have?
A.
A, correct. So what is B given A? 0.5. And what is our A?
0.4.
So when you multiply them, you get 0.2. Then how do we find probability of A union B? Who remembers the formula? A union B, Messi. Probability of A plus what? Probability of B minus what? The intersection of A and B. So what was our A? 0.4. What was our B? 0.5. And what was our intersection? 0.2. So our final answer will be 0.7. Can somebody help me? What is the complement of A? What is the complement of A? It is 1 minus probability of A itself. So what is the probability of A? 0.4. When you subtract it from 1, we get 0.6. And what is the complement of B? It is 1 minus B itself. So since B is 0.5, 1 minus 0.5 is 0.5. Who can help us find the probability of A given B? What's the formula for A given B? Which letter goes down?
B.
And what do we have on top?
A intersection B.
And what was our A intersection B? 0.2. We found it here, right? And what's the probability of B? 0.5. When you divide this into there, we get 0. What? 4. So this is how we get our conditional probability. Now, are these events mutually exclusive? What is the rule for mutual exclusiveness? The intersection must be 0. A intersection B must be 0. But in this case, our intersection was what? 0.2. Is this the same as 0? No. So therefore, they are not mutually exclusive. The A intersection B is actually 0.2. So they are not mutually exclusive. Are they independent? You need to use the rule. There are 2 rules or 3 rules that we said A given B must be equal to A if they're independent. If you're using B given A, we're maintaining the top guy. B given A must be equal to what? Probability of B. All right? This denotes that they're independent. Then you just compare. It's an issue of comparing. What was our A? Our B given A, 0.5. Our B is 0.5 as well. Are they the same? Yes. So 0.5 is equal to 0.5. So in this case, we can conclude that these are what? These are independent. Now, when we're using the tree diagrams to explain the concepts, for instance, if probability of A is 0.4, probability of B is 0.6, and probability of A, D given A is 0.1, probability of D given B is 0.04. Now I want you to get me right because it's a tree diagram I want to do. I'm going to use 2 methods. So tree diagrams is what we call the prior probability, the original probabilities. The probability of A is 0.4. The probability of B is 0.6. This mouth that we are seeing here is adding up to 100%. So A and B, these are called the original, the prior probabilities. Then the branch which is coming there, you read it as D coming from where? A. D is branching off from A. That is D given A. This is 0.1. Then D coming from B is 0.4. So notice that the conditional probabilities don't always add up to 1. But the key probabilities, these ones, they always add up to 1. Then when I multiply this guy and that guy, remember, if the bottom guy kisses the given intersection, automatically you get an intersection. So this will become what? D intersection A. Why? Because D given A was multiplying to A. So here I'm getting 0.04. So D, probability of B times D given B. I'm going to get probability of what? D intersection what? B. Because this is the denominator, the multiplicand. So if I multiply these two, I'm going to get 0.24. Then I told you that when you're multiplying 2 intersections, you get the common letter. What letter is common here? D. So if I add this answer and that answer, what I'm going to get is the intersection. So this is 0.064. That is the sum of these 2 intersections. Then the next question they'll actually ask you, now what is the opposite of this? What is A given D? So expanding this, A given D will be A intersection D over the probability of D. Remember the D comes down, then intersect the two letters. So what is A intersection D? It is 0. What? 0.04. What is probability of D? 0. What? 0.64. So this will give you 0.625. All right. Look at this carefully before you ask your questions. Has anyone been left behind somewhere? Can I repeat that? Has anyone been left behind? Okay. So it's a pattern that you need to understand. So I'll now show you how the question comes in an exam setup so that you appreciate what I've just explained just now. I've sent you a pamphlet on the group that you can use to understand what I'm talking about. Okay. So a question may come like this. Just pause it. Let me try to look at, trying to avoid the tutorial sheet you had today, first of all. So in a factory, 4 machines produce the same product. Machine A produces 10%, B 20, C 30, 40, D. So already these are they adding up to 100? That's question number 1. Yes. So these will make your prior probabilities. There's machine A, machine B, machine C. So what's the probability for machine A? 10%. So you put 0.1. What is probability for machine B? 20%, which is 0.2. Machine C, 30%, which is 0.3. And machine 4, 40%, which is 0.4. Are we together so far? Then we are told that the
Yes, we are.
of defectives are given as follows. Machine A, 0.01. So what do we say? Defective coming from where? A, 0.001. Then machine B defective is what? D given B, 0.0005. Then probability of C being defective, so defective coming from C, 0.005, 2 zeros. And probability of what? Defective coming from machine D, that is 0.002. Are we getting some sense so far? So when I multiply this and that one, I'm going to get the probability of A intersection what? D. When I multiply these two, I'm going to get B intersection what? D. This will be C intersection what? D. This will be D intersection what? Small d. All right, that's by multiplying these ones. So the values I'm going to get here, okay? For W, X, Y, Z, for instance. Then when I top them up, this is the probability of what letter? The common letter. That is letter D. Because there's D here, there's D there, there's D there, there's D there. So what I'm going to get is what? The probability of the common letter D. So what they'll ask me is that if randomly the probability of an item was selected, what's the probability that it came from A, B, C, or D? What they're actually asking is you find the total. This one divided by that. That is the probability of A given D, the reciprocal, the opposite of that. This answer, Y divided by XX, you get B given D. That is how you're supposed to go about it. So now we can look at the example that we had in class so that we understand this concept properly. So in class, he looked at the following two questions. He looked at the mambo, example 28, and he looked at the contraband. Which one do I look at? Okay, maybe I'll look at the contraband in the evening. I only have 6 minutes. Let me look at example 28. Then we end for now. Okay. This will be easy, don't worry. So a jar contains how many marbles? 10 marbles, 7 black and 3 white. So can we draw the tree diagram so far? So how many marbles we have? Black, there are how many? 7. White, there are how many? 3. The total marbles are how many? 10. So probability of the black marble is simply 3 out of what? 7 out of 10. Then the probability of a white marble, it's what? 3 out of 10. Are we together so far? So here we have probability of black, 7 out of 10. Probability of white, 3 out of what? 10. So far, this information we already have. Anyone behind so far before I proceed? So we are told that 2 marbles are drawn without replacement, which means the first one is not put back before the second one. All right, so what's the probability that both marbles are black? So let's finish the table together before we start answering the question. So if I get a black and the second one is black, so meaning the number of the blacks will reduce from 7 to what? To 6. And the total will reduce from 10 to what? To 9. But if I get a black and now a white, what will happen? Which number will reduce? The number of the white marbles. And apparently the white marbles are how many? Yeah, 3. So they will now from 3 they will go to 2. So this is 2, and the total will reduce to 9. Are you following? Please agree with me so that we move together. Then
Yes, we are.
we go here, black and white. So we started with white, then we go to black. So the white marbles will remain the same, but the black marbles will reduce. Okay, since we're getting, so from 7, they'll reduce, they'll go to what? To 3. So we started with white, then we go to black. So what will happen to the number of black marbles. Are we moving together? Have I left anyone behind? Can I repeat what I've just explained?
Yes, repeat yourself, Collins.
The jar has 10 marbles, 7 are black and 3 are white. So 2 marbles are drawn without replacement, which means that the first one is not put back before the second one is drawn. So what's the probability that both marbles are black? So we first have 7 out of 10 and 3 out of 10. So when you total up, this is 10 out of 10. So now we're going to consider what we are picking. So we pick a black, then black. So we reduce in the number here. All right. So from 7, it will be what? 6. All right. From 7 to be 6. Then this one will remain 3 because the total must be what? We're just looking at the top part that we're getting. So this is what? 7. Then this has reduced by 1 to 6 out of 9. So meaning the white ones will remain as what? 3. So the totals must always add up to the total number. So this is 9. This is 9 out of 9. Then when we go to the second one, we are looking at the number of whites. So white, if the white is picked and the other white has been picked consecutively, so from 9, from number of 3 marbles, they reduce, they go to 2 out of 9. Okay, and meaning we leave the black marbles as they are, which is 7 out of 9. So make sure that these ones are adding up to 9 out of 9. Now the question is, what is the probability that both marbles are black? So we're looking at black and black. Then here, what's the probability that one marble is exactly one marble is black? So we can have black, white, or white, black. So now black and black, remember I was saying that and means multiplying. So black and black means we're multiplying this and that. So can we multiply 7 over 10 times 6 over 9? So we're going to multiply here to get our final answer. Just because of time, I'll explain that again. Let me just use our. So here, if 2 marbles are drawn, so going black and means multiplying. So the first one is black, the second one is black. So we're going to have 7 out of 10 times 6 out of 10, which is 0.40. But if we're getting black and white, so we start with black and white. So this will be 7 out of 10 times, if the second one is white, so meaning we're going to have 3 out of 10, because when we picked one black one, we had a chance of 7 out of 10. But since one black one has come out, so how many balls are remaining? There are 9 in total. And all the white are still intact. So the chances of picking a white ball is 3 out of 9. So when we apply this, we get 0.23. Now what's the probability of picking a white, then a black ball? So white initially, out of 10, we have 3 out of 10. But because one white has come out, the total number of balls is 9. So the black balls are still 7, but the total is 9. So it will be 3 out of 10 times 7 out of 9, which is 0.23. Then finally, to pick a white and a white one. So the first time we had 3 out of 10. But because the total has reduced from 9 from 10 to 9, even the white ball, because we've collected one white ball, now there are 2. So the next chance would be 2 out of 9. When you multiply them, we get 0.07. Then now you need to place accordingly based on the question. What's the probability that both balls are black? So black and black is 0.47. That is black and black. And they ask what's the probability that you have exactly one black marble. So where do we have exactly one black marble? There's here and there's there. So you need to add these two. 0.23 plus 0.23. And means what? Multiplying, or means what? Adding. So we can get black and white or white and black. These are the two combinations. So you add these two, which gives you 0.46. So we explain much of these ones later on, but for now we end here unless there are any burning questions.